Okay, in this video we're going to do kind of a fairly brief review of lines, how to find the slope, how to write the equation of the lines, how to graph lines, all that kind of stuff. So the first thing we're going to look at is just a review of the slope of a line. And so we say the slope of a line traveling through the points x1, y1, and x2, y2 is defined to be, we use the letter m, and that's going to be y2 minus y1, so that's the change in y divided by x2 minus x1 is the change in x. So often you've probably heard in the past it's called the rise over the run. And so the first thing we're going to look at is to find the slope and the y-intercept given the graph of a line. So here is a snapshot of two different graphs here. So we're going to find the slope of the lines. I'll show you two ways of doing that. We can read it right off the graph, and we can also use our slope formula, the y2 minus y1 over x2 minus x1. Okay. So on the first graph there for A, I'm going to highlight in red there two dots there where the grid lines meet. And so that gives us the ordered pairs 0, 2, and 4, 0 to work with, and we'll find the slope. So it's going to be, we'll do, this is our y2 minus our y1, and then we'll have to stick with that, and then 4 minus 0 on the bottom, 4 minus 0 on the bottom. So that gives us negative 1/2. Now the other way to think of it is the rise over the run. So we always traveled to the right when we're talking about this. So to get from the 0, 2 to the 4, 0, we have to go down 2, and then to the right 4. And so that'll give us, again, that negative 2 over 4, and negative 2 over 4 reduces to negative 1/2. The y-intercept is going to be 0, 2. And then later on, we're going to write y equals mx plus b. We can go ahead and do that. Y equals m, x plus b. M is your slope, and b is the y-coordinate of your y-intercept. And so that would be the equation of that line, and we'll learn, well, it's not really learning, it's just a review of graphing lines in y equals mx plus b. I think earlier in a previous video we've done graphing using the x-y-intercept method. Okay, so I've marked 2 points on the line B. So I've identified one of them as minus 3, and I've identified 0, minus 2. And that, in fact, is our y-intercept. So our slope, I just got to stick with one of my points is the first point, one of my points is the second point. Okay, so minus 2 and then minus negative 3. So y2 minus y1, and then it'll be 0 minus negative 3 for the x2 minus x1. And we're subtracting a negative, so they'll switch the signs, and that'll become 1/3. Okay, so y is going to be equal to 1/3 x minus 2. To travel from the 2 points being negative 3, to 0 and minus 2, we need to travel up 1, and to the right 3, so our rise over our run is 1/3. Okay, so that's rating the slope, and we can actually come up with the equation of the line if we're given the graph there. Two different ways of finding the slope, one using the slope formula, and then two counting up or down from 2 points that live on the kind of the intersection of the grid lines of the xy plane. Okay, the next thing we're going to do is we're going to find the slope of the line that travels through 2 points. So this time we won't be given the graph. We'll just say, okay, find us the slope of the line that travels through a pair of points. So we'll look at 1 and negative 3, negative 2 and negative 5, and will be equal to, and so this will be our x2, y2, x1, y1. So y2 minus y1 will be negative 5 minus negative 3 all over negative 2 minus 1. And so that's going to give us negative 2 over negative 3, which becomes 2/3 as our slope. Okay, let's take a look at another one. We're going to look at 2, 7 and 3, 7. And notice that the y-coordinates are going to be the same. So that's going to tell us something in a minute here when we actually find the slope. So it's going to be 7 minus 7 over 3 minus 2, which is 0 over 1, which is 0. If I were to do a super rough sketch, a horizontal line is going to have a slope of 0. So if your y-coordinates are the same, then it's going to be a horizontal line. Horizontal lines have a slope of 0. On the other hand, if the x-coordinates are the same, for instance, through the points 4, 5, and 4, negative 9, we'll keep consistent with what my notes say. Negative 5 would be fine too. Okay. So it was a negative 9 on the notes. Do that. Negative 9 minus 5 over 4 minus 4. And so that's going to give us, instead of negative 10, that's going to give us a minus 13 over 0. And thou shall not divide by 0. So that is undefined. Okay. And so if we do a rough sketch, there's our points. And in fact, I had changed it to go through minus 9 down here, but you can still see that it's all on the same vertical line there. So vertical lines are going to have an undefined slope. If it's a horizontal line, it's going to be a slope of 0. Okay, so let's continue on. And I'm going to look at two different formulas, the point slope formula and then the slope intercept form. So the point slope formula, given a point x1, y1, and the slope m of a line, the point slope formula is y minus y1 equals m times x minus x1. And sometimes I may not be given a point and the slope, I may be given 2 points, and so from that I'd have to go find the slope. So the procedure for writing the equation is plug in for the x1, y1, and m. After you've done that, solve for y. You're done. We also have the slope-intercept form, and if you're given a point x, y, and the slope m of a line, the slope-intercept formula is y equals mx plus b, and the procedure for that is plug in for the x, y, whatever you're given, and also the given slope m. If you're given 2 points, find the slope first, and then just use one of the points as your x, y. Doesn't matter which one. Solve for b, and then write your equation y equals mx plus b with the values for m and b. So there may be slightly more work for the slope-intercept form, the y equals mx plus b. So we're going to go through a couple examples where we write the equation of the line. So let's go and see what happens. Alright, so we're going to find the equation of the line using both the point slope formula and the slope-intercept form. Kind of compare the two. So the first one we're going to look at is through the points, well, just through a point, 1, 2, and then we're going to be given the slope of negative 3. So first, using point slope formula, y minus y1 equals m times x minus x1. Well, y minus 2 is equal to negative 3, x minus 1. Go ahead and distribute that negative 3, and then add 2. Y equals negative 3x plus 5. So that's using point slope formula. Now if we're going to use y equals mx plus b, we're going to replace the x and the y with 1, 2, and m with negative 3. And then we're going to solve for b. So negative 2 equals negative 3 times 1 plus b. Add the 3 to both sides, and we get 5 is equal to b. And then we get y is equal to negative 3x plus 5. So we're going to get the same thing. I think it's probably slightly more work to do the slope-intercept form, even though it may not look like that with the number of lines we've written here. It tends to be a little bit less work here. Okay, let's do another one. So same instructions, but this time they're going to give us 2 points. And so if they're giving us 2 points, then when we write down our point slope formula and our slope intercept form, what we're going to realize is we're missing m, and so we have to go find it. So we're going to do y2 minus y1 over x2 minus x1. And simplify that down, minus 4 over minus 4, so that gives us a slope of 1. Okay. Now at this point, when we're substituting in for x1 and y1, it does not matter which one we use. 2, 7, or minus 2 and 3, we're going to get the same equation of the line. It's kind of up to you. I usually like to use the point that doesn't have any negatives, if possible. Maybe if it has a 0 in one of the coordinates. But I'm going to go ahead and probably use the 2, 7. So y minus 7 is equal to 1 times x minus 2. So y minus 7 is equal to x minus 2. Add 7 to both sides. And so y is equal to x plus 5. If we're doing y equals mx plus b, you're going to replace the x and y with 2 and 7. So 7 is equal to 1 times 2 plus b. Subtract 2 from both sides. Get your b, and we end up having the same equation. Okay, so that's kind of the norm is what's going to happen if you're writing equations of lines. We'll look at the two outlier cases that can happen when we're doing this. So let's see what we got going on here. Okay, so we're going to look at through the points 1, 2, and 1, 5, and we need to find our slope. So it's going to be 5 minus 2 over 1 minus 1. That's going to be 3 over 0, and that is undefined. And if you remembered, if you had an undefined slope, that meant it was a vertical line. So vertical lines are going to have the form x equals whatever the repeated value is. So you see how these are both 1. That means your x is going to be 1. That's going to be the equation of the line there. So if you get an undefined slope, x equals. Okay. On the other hand, if we run into perhaps a horizontal line, okay. So here we got, go back just a little bit. We got repeating y coordinates. So when we do y2 minus y1, 2 minus 2, over x2 minus x1, 3 minus 5, we're going to get 0 on the top and negative 2 on the bottom, so that's going to be equal to 0. So if you had a slope of 0, that meant you were a horizontal line, and it's going to be y equals whatever the y value is for your coordinate. So that's going to be y equals 2. Okay. All right. So we're going to look at a little bit more here. So we're going to do a little bit of graphing, y equals mx plus b. Okay. So graph the following lines. We have line A, line B. We're going to identify the slope and then the y-intercept and use that information to graph the line. Okay. So the slope here is negative 4 over 5. So you're going to go down 4 and right 5. And what we need is some sort of line, some sort of point to get us started. So we do have a y-intercept of 0, 2. So that's where we're going to start. We're going to start at 0, 2. And then from that, we're going to count down. From that, we're going to count down 1, 2, 3, 4. And then to the right, 1, 2, 3, 4. Oh, did I mess it up? It looks like it. We'll have to redo this. Let's count it again. I think I got one of my points off here. All right, so we're gonna go down. 1, 2, 3, 4. No, I'm okay. I didn't do a very good job of counting down. So good mistake to make there to illustrate there. And then to the right, 5. 1, 2, 3, 4, 5. So it was fine. I didn't do a good job counting down. So we're fine. And so then we connect our dots and draw our line. Okay. And then I'll label it at the end here. We'll also graph y equals 3x minus 1. And the slope is going to be 3. We can write that as a fraction of 3 over 1. So we're going to go up 3. And we're going to go to the right 1. Y-intercept is minus 1. So we'll put that point in. And then we're going to go up. Well, not with the eraser. And we're going to go up 1, 2, 3. And then over 1. So that looks good. Connect our lines, or connect our points, draw our line, and then label our 2 lines. Okay, we're going to look at a real brief review of parallel lines. So parallel lines are going to have the same slope. So 2 lines are parallel if they have the same slope. or both are both vertical lines. So if they both have an undefined slope, then they're going to be vertical lines. Two lines are perpendicular if they have opposite reciprocal slopes, or one line is horizontal and the other is vertical. So for example, if we had m is 3, then the perpendicular would be the opposite reciprocal, so opposite sign would be negative, and then flip 3 over to become 1/3. Or for example, if we had m was negative 2/5, the perpendicular slope would be the opposite sign, which would make that positive, and then the reciprocal. Another thing you can test for perpendicular lines is you can multiply the two slopes you think that might be perpendicular, and if you're getting an answer of -1, then that's another way of verifying that two lines are perpendicular, of course, with the exception of horizontal and vertical lines. Okay, so we're going to do an example where we're given a line, and then from that we need to construct, and we're going to give it a point, construct a parallel and perpendicular line through a given point to the given line. Okay. All right, so we're going to be given the line f of x equals -2x plus 5, and we're going to find the line through 3, 7 that is parallel to this given line. Now, parallel, we're going to have the exact same slope, so slope being -2, and we have our x1, y1 of 3 and 7. So I'm going to only do the point slope formula here. So y minus y1 equals m times x minus x1. So y minus 7 is equal to -2 times x minus 3. Distribute that -2 through, and then add 7. All right. So there is our parallel line through 3, 7, and parallel to the line -2x plus 5. We're going to do the same thing, but this time we're going to go perpendicular. So we want the line through 3, 7, but this time we would like it to be perpendicular to f of x equals -2x plus 5. Perpendicular slope will be the opposite, so it'll be positive, and the reciprocal of 2 is 1/2. Our x1, y1 will again be 3 and 7. So you have y minus y1, so y minus 7 is equal to 1/2 x minus 3. Distribute your 1/2. 14 over 2 is 7. 14 over 2 is 7. 14 over 2 is 7. Okay, we'll come over here. Y is equal to 1/2 x plus 11 over 2. Okay, and that is our perpendicular line. The last problem concerning lines is kind of just an application of some skills we already have, and then we'll also look at a real brief example of finding some x or y intercepts again. So we're going to be given a piecewise defined function. Well, it's a piecewise defined function. We got to come up with the functions there. So here we have 3 different pieces. So we have 2 kind of like diagonal lines, and then I have a horizontal line segment. So the horizontal line segment is going to be nice. For the diagonal sections, you have this piece here and then this piece here. We're going to have to come up with the equation of those lines, and the first one is from -6 to -2, so they were more than generous to come up with that for us. And then they said, okay, well, here's that horizontal piece right there. And then the 1 to 6, that's this piece right here. Okay, so what we got to do is for each line segment, well, with the exception of the horizontal line piece, is to find 2 points, find the equation of the line. All right, so the first one from -6 to -2, we're going to find the slope. Okay, so our points are -6 and 3, -2 and 5. Change in y, 5 minus 3, over the change in x, -2 minus -6 will be 2 over 4, which reduces to 1/2. Now I need to pick one of the points, doesn't matter which one, and put them into the point slope formula. So y minus 3 is equal to 1/2 x minus -6. So y minus 3 is equal to 1/2 x plus 3, and then we'll add another 3 to both sides, and we'll get 1/2 x plus 6, and that is the first piece there, so we'll fill that in. Okay. The second portion is a horizontal line at 4, so that's going to be y equals 4. Now, because it already says fx right there, that's our y, so we don't need to say y again, so that portion is 4. And then the final piece there, we'll go ahead and find 2 points on the graph of the line there. So 1, 3 looks good, and 2, 1 looks good. So 1 minus 3 over 2 minus 1 is going to give us a slope of -2, and then we're going to put that into the point slope formula. So y minus 1 is equal to -2 times x minus 2. So y minus 1 is equal to -2x plus 4, distributing that -2. Add 1 to both sides. Y is equal to -2x plus 5. And there you have it. There's your 3 line segments. So not super difficult. All it is an application of kind of the first problem we were doing, where we're finding the slope, and then writing an equation of a line. So a little bit of application of some of the stuff we've done. Okay, so the last thing we're going to look at is we're going to be switching gears a little bit, kind of a little bit of review of finding x and y intercepts, and we're going to look at 2 different equations here. So one of them is going to be it's probably going to be an ellipse, but we don't necessarily know that at this point in time. But anyways, we're going to find the x and y intercepts of 36x squared plus 25y squared is equal to 900. So if we're going to find the x-intercept, that means the y is equal to 0. So that whole 25y squared, that's 0. So we got 36x squared is equal to 900. We're going to divide both sides by 36. X squared is equal to 25. To undo the square, we'll square root. Don't forget your plus or minus. So x is equal to plus or minus 5. X-intercepts are 5, 0, and -5, 0. To do the y-intercept, it's almost the same thing. Let x equal 0. So that 36x squared term is gone, and we have 25y squared is equal to 900. Divide both sides by 25. Y squared is equal to 900, not 900. Y squared is equal to 36 after we do the division there. Take the square root. Don't forget your plus or minus. Y is equal to plus or minus 6. Y-intercepts are 0, 6, and 0 minus 6. Okay, we're going to look at one other equation. Y equals 2x plus 5 over x minus 3. Same process, finding the x-intercept. That means the y equals 0. 0 is equal to 2x plus 5 over x minus 3. If we want, we can mention our restriction, and that's x cannot be 3. I don't think that's going to come into play here, but as a reminder, I'm going to go ahead and multiply by the common denominator, clear the fraction. Okay. And so when we do that, x minus 3 times 0 is 0. 2x plus 5 over x minus 3 times x minus 3. Those x minus 3's will absorb, and we're left with 2x plus 5. We'll subtract 5 and divide by 2, and that gives us our x, and our x-intercept is -5/2 and 0. To find the y-intercept, it's even nicer. You plug in x equals 0. So y is equal to 5 over -3 because 2 times 0 and 0, those are both gone. Okay, so then we get the y-intercept to be 0 and -5 over 3. Okay, so I think that's about it for this video, so we'll see you next time.